Okay, good morning everybody. We start again the next lecture I will give. My name is Jan van Dam and I come from the Netherlands. I am very thankful for the organizers to invite me to present my work. We did in the past on biorenewables and materials for building. I hope I can bring some inspiration to you to be equipped for the context you are facing, and I hope this will be a very successful 2-day seminar. I'm working in an institute in Wageningen, and that is linked to the university. It's not a university. We do private work for private companies and for government on food and bio-based materials. That is for both the processing and the logistics of food products, but also for bio-based products. We have basically two divisions to work on development of bio-based products. That would be dealing with chemistry, with industrial processing, with industrial process products, and these are all based on plant materials. Plant materials or sometimes animal resources, could be like shrimps that make chitin. We also work on that. I will explain a bit about the Dutch situation. We have a very densely populated country. We have a very restricted area for bulk production of biomass, and we have very specialized productivity farming. That means we have fruits and vegetables being produced in greenhouses that are being supplied to the industry and being packed and transported all over Europe and even all over the world. You know, the Netherlands is very famous for its flowers, and these flowers are being distributed through the Netherlands. They're not all grown in the Netherlands, but we have a trading tradition, and therefore we have a very good logistic organization. For us, the bioeconomy, we think it's one of the reasons to work on biomaterials is that it's the solution for sustainable development. We have our challenges in the Netherlands, and that is not only for the Netherlands, that's worldwide. We want to reduce oil dependency. We want to see what kind of biomass imports we can use and convert, like we do now for oil, that we can make new products based on biomass. So we look for how to collect it, how to process them, and to use them for processing systems, like done in the current petrochemical industries. So biorefineries are very much focus of attention. It should be similar to petrochemical refining. And of course, we look for export value-added green chemicals. Our activities in this field are dealing with advice for CO2 neutral production, alternative biomass farming, like energy crops, also crops from the sea, algae, seaweeds, sustainable sources for imports for fuel and chemistry, and bio-based products. And that's one of the reasons why I was before in Malaysia to look at the palm oil industry. What is the residues that are being produced here, and what can we make from them? And of course, carbon emission trade and the development with the CDM mechanisms are very driving forces to develop this bioeconomy. So CO2 neutral production is the highlight of everything. And we feel there's a transition process going on in in many countries, but also in the Netherlands, towards more bio-based materials. So renewable resources for energy and also for industries. The use of these biomass from industrial residues is therefore one of the issues that is one of the central focuses, because there's in the food production chains all the straws, all the chaff, all the hulls are being wasted, and these can be used to make value-added materials and green chemicals. And for me, building materials is one of the biggest issues here. Where do we get those biomass residues from? That would be agricultural crops producing sugar for ethanol and fats oil for biodiesel, but there's much more than this. We can look at that. We have been going into this topic for a long time, and we have been identifying a number of biomass crops that are the most interesting. There's a lot of biomass underutilized. That's agricultural residues in the first place, but also food industry waste. When you look at the food industry, what is eventually being consumed by humans, it's a large part of that is being wasted either after the catering or during preparation. Then there is the forestry crops. That forestry, it contains not only the wood for the timber or the wood chips, but there is also the residues from the pulp paper filtering, the black liquor, the waste paper. All those residues can be used to make new things. Animal waste, of course, it's the source for carbon and energy. Municipal solid waste, sewage, and marine crops are very much underutilized. So there's much more carbon to be used than we now use. If you look at where are those crops around, of course, palm oil is highlighted red in this area, and that's not coincidence, because Malaysia is very well known for this palm oil, and I suppose this is something I shouldn't tell you. But the palm oil residues, there's the empty bunch, there's the palm oil mill effluent, the pommy that's polluting, that's a problem. Fiber, shell, trunks, and leaves, I will come to that later. There's a lot of other crops you can look at, rubber, rice, sugarcane, all produce residues much more than the material we really eat. I will give also an example on coconut later. Banana is another raw material that's being rotting away in the fields a lot, where we can make building materials from. So, bio-based materials, why would we go for that? Because when you use biomass for energy, it's very quickly returned the CO2 in the atmosphere. A better way is to fix the carbon in longer-term uses, like Luc already mentioned, that when you use it in bioplastics or in building materials, the material, the CO2 is being fixed for a longer period. I want to say a few words about what's the driver of this all. That's, of course, the CO2 emissions. We all know there's concern about our climate, and that's our own fault that we do it. This is CO2 concentration. This is a slide I took from this, the climate notes from the ICCP. They have shown here that along with the temperature change, it goes parallel with the atmospheric CO2 concentrations and the human-caused emissions. What are the causes